So we are now done with integration, and the focus of this lecture is going to be on sequence and series. So let's now first talk about sequence. A sequence is basically just a list of numbers that never ends. So I can write this sequence using the bracket notation. Now in this bracket notation, the thing that goes inside the bracket, the an here, so this is going to be the terms of my sequence. So this is going to be the number in the sequence. So this is the things that go inside the parentheses. And down here, n equal to 1, this little n here is going to be my variable. So this n is going to be my variable. And this n equal to 1 here is basically just going to be the starting value of my variable. So now let's take a look at the first example that we have here. If I want to write the first 5 terms of this sequence, so it's going to be just, so my n goes from 1 to infinity, so the first term is going to be just 1 squared plus 1. So I'm going to have, let's see, 1 squared plus 1. And when n goes on to be 2, so that's going to be 2 squared plus 1. And then 3 squared plus 1, 4 squared plus 1, 5 squared plus 1, and so on. So if I want to compute this out, this is going to give me 2, let me see, 5, 10, 17, 26, and so on. So here is the first 5 terms. So here are the first 5 terms for my sequence. Let's take a look at the next one. I have negative 1 to the n, where n goes from 1 to infinity. So n goes from 1, 2, 3, 4, 5, and forever. So if my n is equal to 1, so that's going to be negative 1 to the 1, negative 1 to the 2, negative 1 to the 3, negative 1 to the 4, and then negative 1 to the 5, and so on. Now then, negative 1 to the 1, this is just negative 1. Negative 1 squared, this is just 1. Negative 1 cubed, this is once again negative 1. Negative 1 to the 4th is going to be 1, and negative 1 to the 5th is negative 1. We can notice that the numbers in the sequence is actually just negative 1 and 1, and they keep alternating between the two. Now let's take a look at the next one. I have n over n plus 1. So once again, when my n is 1, this is going to be 1 over 1 plus 1, which is 2. When my n is 2, I'm going to have 2 over 2 plus 1, which is 3. When my n is 3, I'm going to have 3 over 3 plus 1, which is 4. And then I'm going to have 4 over 4 plus 1, which is 5. And then 5 over 5 plus 1, which is 6. So here is my numbers in this sequence. Let's take a look at the next one. Notice how in the next one, my number is going to be just 3n plus 1. But for this sequence, the starting value of my variable is now 0. So instead of starting at n equal to 1 like all the other three, I'm going to start my value with n, with my variable n being 0 now. So I'm going to have 3 times 0 plus 1, 3 times 1 plus 1, 3 times 2 plus 1, 3 times 3 plus 1, and 3 times 4 plus 1. So here are the first 5 terms of this sequence. So this is going to give me 1, 4, and then 7, 10, 13, and so on. And here's how we go from the bracket notation to a list of number. We can go the other way as well. If we have a list of number and we want to write that as a bracket notation, it's going to be just a matter of reading the patterns. Like if we see the first one here, 11, 21, 31, 41, 51. So we can see that the first term, this is just 10 plus 1. The second term, 21, this is 2 times 10. So let me actually write 10 times 2 plus 1. 31 is going to be 10 times 3 plus 1. The next one is 10 times 4 plus 1. And the next one is 10 times 5 plus 1. We can see that the pattern here is probably just 10 times the whatever number that is, and then plus 1. So the general term for this sequence is going to be just 10 times n plus 1, where my n starts from 1 and go all the way to infinity. So notice how the first 10 here, this is just the 10 times 1, by the way. Okay, so here we go. The next one, 1, 2, 4, 8, 16. So you can probably kind of already see this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4. So the general term for this sequence is going to be just 2 to the n, where my n goes from 0 and goes all the way to infinity. Now then, if I want to change the starting value for my sequence, I can actually rewrite this thing to start from 1 as well. To do that, I can see that this is the same as 2 to the 0 is 2 to the 1 minus 1, right? 2 to the 1 is going to be the same as 2 to the 2 minus 1. Now, let me actually change the color here. 2 to the 1 is the same as 2 to the 2 minus 1. And 2 to the 2 is the same as 2 to the 3 minus 1. 2 to the 3 is the same as 2 to the 4 minus 1. And 2 to the 4 is the same as 2 to the 5 minus 1. And so on. So on. So you can kind of see the terms in this sequence are 2 to the 1 minus 1, 2 to the 2 minus 1, 2 to the 3 minus 1, 2 to the 4 minus 1, 2 to the 5 minus 1. So the general term in this sequence is going to be just 2 to the n minus 1. And now my n is going to start from 1 and it goes all the way to infinity. This is called the shift of index, and you might have seen this when you write a computer program. So instead of using the variable n when n goes from 0, I can use n minus 1 instead, and now my n can start off at value 1. So let's take a look at the next example here. I have negative 1, 2, negative 3, 4, negative 5, and so on. So it seems like the number in the sequence is just 1, 2, 3, 4, 5. So it's going to be just the number n. But it can't be just the number n because I have the negative sign here that keep alternately showing up. So I can use what we see earlier. I can put negative 1 to the n up front. So this is going to be negative 1 to the n times n, where my n goes from 1 to infinity. And if you check the number in my terms here, the first term is going to be negative 1 to the 1 times 1. This is negative 1 squared times 2. This is negative 1 cubed times 3. Negative 1 to the 4 times 4. Negative 1 to the 5 times 5. So this is the correct answer for part C. For part D, so this looks a little weird. Let me try to see. It seems like the numerator is 4, 5, 6, 7, 8. So this is just a number starting off with 4. And the denominator is 1, 4, 9, 16, and 25. This is just the square of a number. This is 1 square, 2 square, 3 square, 4 square, 5 square. So if I want to write the general term for this sequence, so let me do the denominator first. The denominator is going to be just n square. And then my n is going to go from 1 all the way to infinity. Now for my numerator, I have 4, 5, 6, 7, 8. So this is just 1 plus 3, 2 plus 3, 3 plus 3, 4 plus 3, 5 plus 3. So my numerator is going to be just n plus 3. However, I still have this negative sign to deal with. I can use the same trick that we see earlier, but notice that the negative sign shows up at the alternate place that we see earlier as well. So for this, it's going to be just slightly different. So let me kind of write back on the side here. If I have negative 1 to the n go from 1 to infinity, then for this sequence, the first term is going to be negative 1, 1, negative 1, 1, negative 1, and so on. But if I have negative 1 over n plus 1, so I just add 1 to the n here. So this is gonna cause a shift in my number here. So negative 1 to the 1 plus 1, that's negative 1 squared. So now my sequence is gonna start off with 1. So this is gonna be 1, negative 1, 1, negative 1, 1, and so on, which is kind of what we see here. So I'm gonna also put in my bracket here negative 1 to the n plus 1. Negative 1 to the n plus 1. So here is my answer for part D. And before I finish, let me also note that the the answer to this part, so the answer to most part actually is not unique, by the way, because if I do, for example, negative 1 to the n minus 1, so if I do n minus 1 instead, it's going to end up being the same sequence anyway. So I can do n plus 1, n minus 1, n plus 3, anything like that would also work.